answer. The next question. In adiabatic expansion, so during the adiabatic expansion, delta U is equal to 0. Delta U is equal to 0 and it is a internal energy, change in internal energy. Change in internal energy is negative. Change in internal energy is positive. The work done is 0. In an adiabatic expansion, so as you know that in the adiabatic expansion, there is no interaction of the heat from the system with the surrounding. Yes, option B. That is internal energy is negative. So see, if you eliminate the options, you eliminate ಮಾಡ್ತಾ ಹೋದ್ರೆ work done 0 ಇರಲ್ಲ. In case of the adiabatic process, the work done is positive. Okay, the work done is positive during the adiabatic process. So what about the internal energy? So internal energy ಗೆ 3 options ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನ್ ಬರುತ್ತೆ? 0 ಬರುತ್ತಾ, ನೆಗೆಟಿವ್ ಬರುತ್ತಾ, ಪಾಸಿಟಿವ್ ಬರುತ್ತಾ? Yes, so keep yourself mute, students. In the chat box, you can tell whatever you want to tell the answer. Yes, the internal energy decreases. Therefore, the internal energy will be negative anta helbodu. Option B is the correct answer. Okay, option B is the correct answer. Let us go for the next question. The pressure in the tire of a car is 4 times the atmospheric pressure at 300 Kelvin. If this tire suddenly burst, its new temperature will be. So you need to calculate the temperature using the adiabatic process. That is gamma value is given 1.4 anta kottidare avaru. So let us see how to solve this. So for the adiabatic process, what we can use, that is P1 T1 is equal to P2 T2. We can use the formula. So P1 T1 raised to gamma is equal to P2 T2 raised to gamma. Okay. So using this formula, you can calculate. So Priya is getting option D. What about the other students? So ನೀವು ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು. ಸಿ ಏನಂತ ಹೇಳಿದ್ದಾರೆ, ದ ಪ್ರೆಷರ್ ಇನ್ ದ ಟೈರ್ ಆಫ್ ಎ ಗ್ಯಾಸ್ ಇಸ್ 4 times ದ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್. ಸೊ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಅನ್ನ ನೀವು ಪಿ ನಾಟ್ ಅಂತ ತಗೊಂಡ್ರೆ, ದ ಪ್ರೆಷರ್ ಆಫ್ ದ ಟೈರ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 4 times ಆಫ್ ಪಿ ನಾಟ್ ಅಂತ ಬರ್ಕೊಳ್ಬಹುದು. ಕರೆಕ್ಟ್, ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಆಸ್ 4 times ಆಫ್ ಪಿ ನಾಟ್. ದ ಪ್ರೆಷರ್ ಆಫ್ ದ ಟೈರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 4 times ಆಫ್ ದ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಅಂತ ಆಯ್ತು. Then the temperature is given as how much it is? It is 300 Kelvin. If the tire suddenly burst anta andre, the gamma value is taken as 1.4. Okay, now we need to simplify this one and find out the value of T2. So T1 is given, T2 value find out ಮಾಡಬೇಕಾಗಿದೆ. So therefore, sorry, this should be P1 T1 is equal to P2 T2. Okay. Here this equation, the adiabatic process, whatever the equation is there, this equation can be modified as T1 raised to gamma divided by P1 raised to gamma minus 1 anta navilli barkolbodu. So therefore, if I simplify this one for T2, T2 by T1 is equal to, that is T2 divided by T1 is equal to P1 divided by P2 raised to 1 minus gamma divided by gamma anta baratte. Okay. So T2 value keep it as it is. This T2 value keep it as it is. T1 value is 300. Then next, the P1, P2 values are 4 times of one another. Therefore 4 by 1 anta baratte. It is 4 divided by 1 to the power of 1 minus 1.4 divided by 1.4. Okay. So now T2 is equal to ಕೊಟ್ಟಿರೋ options ಅಲ್ಲಿ gamma power ಅನ್ನೇನು simplify ಮಾಡಿಲ್ಲ. So 1 minus 1.4 will be 0.4 ಅಂತ ಆಗತ್ತೆ. So therefore we can go with option D by seeing the solution part. Okay. ಯಾರಿಗೆ ಗೊತ್ತಿಲ್ಲ, please copy down the solution. We will go for the next question. So gamma value is given as 3 divided by 2. final pressure ಕೇಳ್ತಾ ಇದ್ದಾರೆ. They are asking you to calculate the final pressure and volume relation. So therefore in terms of pressure and volume it is P1 V1 raised to gamma ಅಂತ ಬರುತ್ತೆ. Okay, temperature ತಗೊಂಡಾಗ 1 minus gamma ಅಂತ ಬರುತ್ತೆ. Here it will be P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Okay, so now we can simplify this for what? P2 is equal to ಅಷ್ಟೇ ಬೇಕಾಗಿದೆ. P1 is equal to it is 1 atmosphere ಅಂತ ಹೇಳಿದ್ದಾರೆ. Therefore we need to take it as what? 1 ಅಂತ P1 ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತೆ. So simplify ಮಾಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್. P2 is equal to ಬೇಕಂದ್ರೆ P2 divided by P1 is equal to, it is V1 divided by V1 divided by 4 to the power of gamma. It is nothing but what? 3 divided by 2. Okay, therefore it is P2 is equal to, so this is 1 into V1 divided by V1 by 4 to the power of gamma, that is nothing but 3 divided by 2. Okay, so V1 cancel ಆಗುತ್ತೆ. 4 to the power of 3 by 2. So 4 to the power of 3 by 2 andre our Priya is saying option C, 8 atmosphere. Yes, correct answer. So V1 cancel agi 4 raised to 3 by 2 anta barutte. That is 4 cube is 16. 16 square root is, sorry, 4 cube is 64. Then 64 square root will be, for option C is the correct answer. So please copy down the students. Then we will see the next question. Okay, the next question. A monoatomic gas, gamma is equal to 5 by 3, is suddenly compressed to 1 by 8 of its original volume adiabatically. Then the pressure of the gas will change to 24 by 5, 8, 40 by 3, 32 times its initial pressure. A monoatomic gas, gamma is equal to 5 by 3, is suddenly compressed to 1 by 8 of its initial volume adiabatically. Then the pressure of the gas. So it is almost similar to your previous question. You can try it, students. Yes. What about others? It is correct answer. So your V2 is what? Your V2 is 1 upon 8 times of your V1. and gamma is equal to, it is given as 5 divided by 3. So therefore, P2 divided by P1 is equal to V1 by V2 raised to gamma anta agatte. So V cancel agatte. Then you have only 1 by 8. 8 to the power 5 by 3 anta agatte. So 5 cube ಮತ್ತೆ ಅದರದ್ದು cube root ತೆಗಿಬೇಕು. So all are getting option D. Yes, very good. That is option D is the correct answer. Hope so others are also got the answer. The next question. The pressure and density of a diatomic gas gamma is equal to 7 by 5 change adiabatically from PD to P dash D dash. If D dash by D is equal to 32, then P dash by P should be. So pressure and density of a diatomic gas gamma is equal to 7 by 5. Ratios it is given, density ratios it is given, pressure ratio ತೆಗಿಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. So ನಿಮಗೆ already mass, pressure ಮತ್ತೆ volume relation ಗೊತ್ತಿದೆ. So let us see how to do this. As we know that volume of the gas is equal to mass by density anta ಹೇಳ್ತೀವಿ. So therefore density is equal to volume into density is equal to mass by volume ಅಂತ ಆಗುತ್ತೆ. Okay. So therefore ನಾವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೋದು ಅಂತ ಅಂದ್ರೆ, that is P dash by P is equal to, it is yes, 128 is the correct answer. So pressure and volume relation ಪ್ರಕಾರ ಇದೇನಾಗುತ್ತೆ, just ಅಲ್ಲಿ pressure ಇದ್ದಲ್ಲಿ density, volume ಇದ್ದಲ್ಲಿ density ತಗೊಳ್ಬಹುದು. Therefore I can take it as what, D dash by D raised to gamma ಅಂತ ತಗೊಂಡ್ರೆ. So this is nothing but 32, because the density ratio is how much it is. It is 32 raised to gamma value is given as 7 divided by 5. Okay. So if you simplify this, that is 128. Okay. 128 is the answer. So option C is the correct answer. Let us go for the next question. So the next question is, an ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of its original volume. and the gamma value is given as 5 by 3. Then the rise in the temperature is yes, you can try this question in terms of temperature and volume it is. So see, in terms of pressure and volume and temperature, as you know that the formula is, okay, somebody is getting the answer. Option B, let us see. An ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of its original volume. So ಹಾಗಾದ್ರೆ ವಾಲ್ಯೂಮ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ T1 by T2 is equal to V2 by V1 to the power of gamma minus 1. So the temperature T1 value is 300 and T2 keep it as it is, and the volume is 8 by 27 into V upon V. So V will get cancelled, no problem in that. And to the power of gamma minus 1 ಮಾಡಬೇಕಾಗುತ್ತೆ, that is nothing but 5 by 3 minus 1. Yes. So 5 by 3 minus 1 is nothing but what? It is 2 divided by 3. ಹೌದಾ 8 by 27 to the power of 2 by 3 ಅಂತ ಅಂದ್ರೆ 8 by 27 square ಮಾಡಿ first, then you need to take the square cube root of that. So if you do that you will get it as 4 by 9. It is 4 divided by 9 ಅಂತ ಆಗತ್ತೆ. And the T2 value is T2 value you have to find out. So T1 value is given, that is 300 ಅಂತ. Therefore ನೀವು ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, T2 is equal to, it will be T2 is equal to 9 by 4 into 300. Okay. Therefore this is equal to 675 Kelvin. That is nothing but the T2 value, but they are asking you the rise in temperature. So rise in temperature anta kelidag ನೀವು ಏನು ಮಾಡ್ತೀರಾ, that is you just need to subtract the initial temperature, that is 27 degree Celsius ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಮಾಡಿದಾಗ 300 ಆಗತ್ತೆ. Therefore 675 minus 300, it is nothing but what? 375 Kelvin. That is option B is the correct answer. Yes, Priya, correct. Srivaruni, Priya, both are correct. So other students copy down the solution. We will go for the next question. Two identical samples of a gas are allowed to expand isothermally adiabatically, work done is more in the isothermal process, more in the adiabatic process. Neither of them equal in both the processes. Yes. A, more in the isothermal process. Yes, correct. So if you see the graph between the isothermal process and the adiabatic process, the graph of isothermal curve is more than the adiabatic curve. So therefore, a graph alli ನೀವು ಇಲ್ಲಿ work done and calculate ಮಾಡಿದಾಗ isothermal curve curve ಮೇಲ್ಗಡೆ ಇರೋದ್ರಿಂದ ಜಾಸ್ತಿ ಏರಿಯಾ ಕವರ್ ಮಾಡುತ್ತೆ. Therefore, we can say that the isothermal has the more amount of work done. Option A is the correct one. Okay. So let us go for the next question. Which is the correct statement? For an isothermal change, PV is equal to constant. In an isothermal process, the change in the internal energy must be equal to the work done. For an adiabatic change, P2 by P1 raised to gamma is equal to V2 by V1 raised to gamma, where gamma is the ratio of specific heat. Yes, ಯಾವ statement correct ಆಗಿದೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. A. If you are saying option, no, not for this, previous question. Here also option A. But other statements wrong idea, correct idea, adu wrong ide anta. So B option at least it is wrong, no problem in that. What about the C and D? A antu correct ide, no problem. A is 100% true. PV is equal to constant. So C is also wrong. Yakanta andre ನೀವು cross multiply ಮಾಡಿ ತಗೊಂಡ್ರೆ P1 V1 raised to P is equal to P2 V2 ಅಂತ ಆಗಬೇಕು. But ಅಲ್ಲಿ P2 V1 is equal to V1 P1 V2 ಅಂತ ಆಗುತ್ತೆ. Yes, that is also wrong. Yes, option A is the correct answer here, students. Okay, yes, option A correct. Very good. The slope of isothermal and adiabatic curves are related as isothermal curve slope is equal to adiabatic curve slope. Isothermal curve slope is equal to gamma into adiabatic curve slope. Adiabatic curve slope is equal to gamma into isothermal curve slope. Or adiabatic curve slope is equal to half of isothermal curve slope. Yes, Priya, correct. Isothermal curve slope is equal to gamma into adiabatic slope ಅಂತ ಆಗುತ್ತೆ. So equal ಅಂತೂ ಆಗಲ್ಲ. but gamma ಇಲ್ಲಿ isothermal ಗೆ ಬರಲ್ಲ. Yes, option A, C, D are wrong. B is the correct option. Next question. Pressure temperature relationship for an ideal gas undergoes adiabatic change is pressure and temperature relationship for the adiabatic process. PT raised to gamma, PT raised to minus gamma plus 1. Option C, D, I think same. No. Option C and D are both are different. Option D. Yes. Option D is the correct answer. That is P raised to 1 minus gamma into T raised to gamma is equal to constant. That is option D is the correct answer. Okay. The amount of work done in an adiabatic expansion from temperature T to T1 is That's the amount of work done in an adiabatic expansion from temperature T to T1 is. Yes, option D. Sorry, option B is correct. What about other students? Yes, option B is the correct answer. That is R divided by gamma minus 1 into bracket T minus T1. So the next question. During the adiabatic expansion of 2 moles of a gas, the internal energy of the gas is found to be decreases by 2 joules. The work done during the process on the gas will be equal to 1 joule minus 1 joule, 2 joule minus 2 joule. So here, as we know that during the adiabatic expansion, 2 moles of a gas, the internal energy of the gas is found to be decreases by 2 joules. Andre internal energy decrease ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ negative ಅಂತ ತಗೊಳ್ಬೇಕು. The work done during the process. So as we know that during the adiabatic process, the change in internal, the change in ಏನಂತ ಹೇಳ್ತೀರಾ, that is heat will be 0. ಹೌದಾ? So therefore dq is equal to du plus dw. So here the heat is 0. The change in internal energy is minus 2 plus dw ಅಂತ ಆಗುತ್ತೆ. Therefore the dw value will be 2 joules. The dw value will be 2 joules. But ಅವ್ರು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, the work done during the process on the gas will be equal to. So as they are asking on the gas, it will be option D. That is, yes, option D is the correct answer. Okay. In a cyclic process, the internal energy of the gas increases, decreases, remains constant, becomes 0. Yes, option D is the correct answer. That is, the internal energy becomes 0. So see the next question. If the door of a refrigerator is kept open, then which of the following is true? Room is cooled, room is heated, room is neither cooled nor heated, room is neither cooled nor heated. Yes. So it is a day-to-day process, but according to physics, you have to think. Okay. So see, when you open that and feel, no, you feel it cool, but if you keep it open continuously, ಅಲ್ಲ ಅದ್ರ ಒಳಗಡೆ heat ಎಲ್ಲ ಹೊರಗಡೆ ಬರ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Therefore, the room is heated. Option B is the correct answer. Okay, students, option B is the correct answer. The coefficient of performance of a Carnot refrigerator, the coefficient of performance of a Carnot refrigerator working between 30 degrees Celsius to 0 degrees Celsius is 10190. It is based on the refrigerator concept. The coefficient of performance beta is equal to anta think ಮಾಡಬೇಕು. Temperature is given. So if you know the formula in terms of coefficient of temperature, the beta value will be, it is beta is equal to T2 by T1. So T2 by T1 temperature is given as 30 degrees Celsius and the 0 degrees Celsius. So 30 degrees Celsius anta andre it is plus 270. So it is 293 divided by 273. So plus 30 ಅಂತ ಅಂದ್ರೆ 303 ಅಂತ ಆಗುತ್ತೆ. Yes, how much you are getting? Option? Yes, C. Option C is the correct answer here, students. Okay, so this completes the question on the thermodynamics. Next class, we will start with some new topic. Okay. Any doubt is there in today's class? Okay. So in the next class, we will do the kinetic theory of gases. Okay, students.